In the northwest of England lies the city of Liverpool. Beneath the Mersey River is one of the greatest man-made engineering achievements of the 20th century. Over 2.3 kilometers long, it was unprecedented for its time.
Nobody had seen anything of this scale before.
Prior to being known as the home of the Beatles, the global port of Liverpool was experiencing growing pains. Travelling from one side of the Mersey to the other required ferries and lots of time. The growing popularity of cars meant people needed a quicker way to do business, and engineers had the answer.
It's all done by hand-picked, small explosives.
So how did the tunnel's designers figure out how to beat the river at its own game?
It was very, very difficult to control the groundwater.
For centuries, ships transporting goods across the world have navigated the River Mersey into the port of Liverpool. The river was also a vital means of moving goods and people locally.
In the early 1900s, everything had to come across by ferry, people, livestock, horses and carts.
But by the 1920s, use of motor vehicles was increasing exponentially, and engineers searched for a solution to a new phenomenon called a traffic jam. In 1922 alone, 640,000 cars trying to get from Liverpool across the Mersey to Birkenhead caused chaos.
The traffic was building up either side of the river, and something had to be done.
Local engineers got to work, attempting to solve a problem that no one in the world had successfully done yet. Sir Archibald Salvage, one of the city's engineers at the time, appointed a committee to tackle the infrastructure problem. The committee proposed two options: build a bridge or dig a tunnel.
The bridge was a really expensive option compared to a tunnel. They also knew, having come out of the First World War, that a bridge across the river would be a target for enemy bombers.
After several years of debate, the committee voted for a tunnel. The next challenge was to find an engineering genius who could build it. Determined to keep the traffic flowing freely into the city of Liverpool, Salvage asked the government for financial support to build the tunnel.
Chancellor of the Exchequer was Winston Churchill, and they agreed to fund it to the tune of £2.5 million. Sir Archibald Salvage appointed Sir Basil Mott, who was one of the real titans of British engineering at the time, to lead on the project.
Sir Basil Mott had overseen some of the country's largest engineering feats, including bridges over the Thames and installing the first escalators into London's underground. But nothing would surpass the enormous engineering challenge he was about to face.
If there is some joint or fault of the lock, the water can come through that joint, so it can make some severe damage or severe failure of the tunnel.
In the early 20th century, England was just learning how to deal with a new phenomenon called traffic. In Liverpool, engineers were attempting to combat this problem by building an underwater tunnel on a scale that had never been attempted before. Dr. Hyun-Jun Seo of the University of Liverpool has worked on some of the UK's biggest tunnelling projects.
Underground water excavation is very difficult. 100 years ago, it was very difficult to control the groundwater. Under the river, the soil or rock condition is much softer. So during the tunneling, the water pressure control is one of the important parts.
The plan was to build a 2.3-kilometre tunnel under the River Mersey. But with no modern equipment at their disposal, the excavation alone was a dangerous undertaking.
This tunnel was all dug by hand, 1,700 men working on it at its peak, and it's all done by hand-picked, small explosives.
Engineers decided to start with two exploratory pilot tunnels on each side of the river to make sure conditions were safe to continue digging. The goal was for the two tunnels to eventually meet in the middle.
To accurately meet in the middle, they had a depth measuring stick, which they would shine the light across to the next depth measuring stick and make sure that they were coming out at the same level each time.
After 3 years of backbreaking work, on April the 3rd, 1928, the two teams met under the river.
When they met in the middle, they were less than an inch out, so it was very accurate work back then.
Even though the pilot tunnels were a success, plans called for the main tunnels to be enlarged, meaning tunnelers had to dig both up and down. And soon, only a meter of rock stood between the workers and the raging river above. Modern underground construction uses boring machines to seal the tunnels as they go. But workers in the early 20th century had rudimentary technology to keep the mighty river Mersey at bay. More than 1.1 million tons of rock needed to be excavated and removed. Experimentation was necessary to find the best solution to waterproof the walls.
We make a borehole and we take a sample and we know all the ground condition before the tunnel construction, like underground mapping. However, 100 years ago, they don't know the ground condition very well.
Workers installed 100,000 cast iron linings, weighing more than 63,000 tons, all by hand to support the tunnel.
If there is some joint or fault of the lock, the water can come through that joint, so it can make some severe damage or severe failure of the tunnel.
But water wasn't the only issue engineers had to deal with. In the early 20th century, lead engineer Sir Basil Mott's groundbreaking designs for the Mersey Tunnel had managed to protect the tunnel and its crew from the river. His next challenge was to rid the tunnel of lethal exhaust fumes. Combustion engines were passing under the Mersey at a rate of 4,000 per hour. The risk of a catastrophic disaster was high. Sir Basil Mott needed to devise an ingenious plan, or this airflow issue could threaten the entire project. Using a mixture of longitudinal and transverse ventilation, they designed a unique system to vent toxic fumes from the tunnel.
The air is now coming down from the fresh air fan, and it comes down the shaft and it meets these walls. These walls we call our banana walls because they're curved.
The longitudinal system funneled air along channels running parallel to the road. It was then diverted away and the air filtered.
The air's come round the corner along this air invert. To get it on the road deck, you've got this series of holes on the underside. So the air travels up through those, hits a U-shaped structure which sends it off across the road deck at about exhaust level.
The transverse ventilation used a system of ducts in the walls and ceilings to inject air and remove exhaust gases.
The fresh air comes through under the pavement. That air pushes the polluted air through that exhaust duct.
To sustain this system over a 2.5-kilometer underwater tunnel required serious power, capable of delivering 71,000 cubic meters of fresh air every minute, and withdrawing the same amount.
This huge fan, it's 28 feet wide, weighs 25 tons. It can actually create a wind speed of about 36 miles an hour. The building had to be built around them because of the sheer size of them.
Having overcome this mammoth undertaking, on the 18th of July 1934, the tunnel was officially opened by King George VI.
This tunnel was actually described as the 8th wonder of the world when it opened because nothing had been built on this scale before. People came on holiday to Liverpool just to drive through the tunnel. because they'd never experienced driving underwater before.
Not only was it deemed the longest and largest tunnel ever attempted beneath a major body of water, it was by far the most modern and technologically advanced. 2 underwater junctions would service 4 lanes of traffic under the Mersey, between 2 entry and exit points on either side of the river.
The Mersey Tunnels is a 24-hour operation. It never sleeps.
Today, Liverpool has a dedicated team to maintain this massive underwater transit system. Paul Heaton is one of the engineers taking on this crucial role.
The workmanship back in the 1920s and 1930s of the original builders of the tunnel was fantastic. It's left us with a really good structure to maintain.
Yet the power of the river surrounding the tunnel is relentless, and every day water leaks through.
Underneath us now is a huge sump. It spans the width of the Queensway Tunnel. This pump manages to pump out 145 metres cube of water every minute, pushed out by the pump into the main sewers in Birkenhead.
If these pumps fail, disaster will likely follow.
The water would fill up the sumps and it would actually fill up these rooms. We wouldn't have a tunnel because it would be underwater.
But a lot has changed since the tunnel first opened. During its first year, nearly 2 million vehicles passed through. Today, 12.8 million vehicles travel safely through the Mersey Tunnel every year. This groundbreaking tunnel is key to the economic success of the area. The ambition and engineering prowess of the early 20th century builders who dared to tame the Mersey is nothing short of inspiring and remains truly impressive by 21st century standards.